And now, ladies and gentlemen, please welcome Vice President Products, Storage, and Availability, Lee Caswell.
Yeah, great. Thank you. Thank you. Gosh, it's great to be here. I'm thrilled to have you coming to find out about the fastest growing product in the fastest growing market in storage today. Think about that for a minute, right? Right now, hyper-converged, right, is the fastest growing market in storage. If you look this year, it's going to double in size, right? We're going to talk a little bit about what's happening in the market, about how VSAN users, just a quick show of hands, how many of you are using VSAN today? Wow, right? How many of you are planning to deploy VSAN in the next 12 months? Yeah, there we go. See, so what's happening here? I just want to put it in perspective, right? Kind of the darling of the all-flash market, and I've kind of familiar with that, right? Announced that they had added 350 customers last quarter. We're adding 100 VSAN customers a week right now. Think about that for a minute. The scale at which hyper-converged is taking the market is because it appeals to what Pat was talking about in the opening keynote. It's about freedom and control, right? How you go and balance those two. That's where hyper-converged brings a new set of values. So we're going to talk about that today. I'm going to kick off by showing our legal thing, right? There's some future-looking things here, so our legal advisors, I'm not going to read it all, but we will be talking a little bit about futures. I'm going to talk about customers. I'm going to invite one of our leading customers from Chevron up. We're thrilled to have Chris Millett here today. He's going to come up and talk a little bit about his experience with VSAN. And then we're going to bring Christos up. The infamous Christos. Yeah, Christos, there we go. So Christos is going to lead us into what's coming next, right? If you think about the two big disruptors in the market today, flash and cloud, and how we're bringing those together with hyper-converged in a way that's consumable, right, in a world where we've got these dynamics. So let me talk about what's happening. These are when I talk to customers today, these are the big demands. And you heard a little bit about this from Pat today, unpredictable demands. Right? The idea that we've got more IT projects, the digital transformation means you have to respond more quickly. So how do you do that? Right? Classic enterprise storage is it's complex, difficult to go and reconfigure. So the idea of how I scale seamlessly, you'll see that as a theme, right? That responsiveness is one. The second element is, as I talk to customers over and over, right? Let's do a quick show of hands. How many of you have budgets that are going to be lower next year than this year? Yeah. Right? More people or fewer people? Right? It's like, now I have to start thinking. That's the stress level, right? How do you go do and become more responsive at a time where you've got fewer resources and fewer people? And that's where hyper-converged comes in. And then lastly is, how do I go and integrate this, right? Instead of having many silos, how do I integrate this together? And what you'll find is that the hypervisor is a natural point of management simplicity. By bringing in storage along with what we've done already on compute, along with what we're doing on NSX with software-defined networking, you've now got an architectural point of getting simplicity with a common UI. That gives you scale. That's what we're going to talk about, is how we go and resolve the stress, or this stress level, right, of having to do more with less, is what hyper-converged, that's how we fill this game. And if you think about where we are, right, enterprise storage sure is not going away, by the way. I mean, enterprise storage is fast, reliable, available, and yet, at the same time, customers, because of that economic stress, are looking for how they get the simplicity of what's available in the cloud today. That's the dynamic. That's the dynamic we're looking at. And this is where hyper-converged comes to drop in as a way to go and give scale-out and scale-up flexibility based on servers. If you think about that for a minute, right, the idea that I'm leveraging all of my expertise, what it means is you can become an expert in managing enterprise-grade storage without being a storage admin. Right, if you think, I remember when Andy Bechtolstein talked about how TCP/IP was going to win out because there were just simply more engineers working on TCP/IP than on any other competing technology. Well, we've got a lot more people capable of managing servers, virtualization environments than we have enterprise storage. And so we're going to show how this works. And what you'll see today, as we show the dynamics, is that our VSAN architecture, right, is one that gives you operational efficiencies And that means you can go and by natively integrating into vSphere, we're just simply giving you more VMs for whatever server resource you have. That's an architectural distinction in how we've architected our product. And then secondly, right, this 50% savings is the idea that you can now build out systems much, much cheaper than an enterprise kind of engineered system. And the way I think about this is for, if you think back in the RISC Unix days, remember those, right? I mean, you could buy a RISC system that could do anything. It was custom engineered, proprietary hardware, right? Proprietary software, but there were a very limited number of people who were trained to be able to go and build and use RISC systems. What happened was when x86 came around, right, it was NT 3.1, right, that all of a sudden made x86 servers manageable and no longer a toy, right, but mainstream enterprise-grade servers. That's what's happening with hyper-converged. Our version 6.2, which, I don't know, that's 2 times 3.1, I guess. But anyway, our version 6.2 of VSAN, right, is what brought enterprise-grade level functionality to hyper-converged. And that's why you're seeing the massive deployment. By the way, so we announced we had 5,000 customers, largest in the industry today. VMware itself has 500,000 customers, just to give you an idea of the scale. We have 1% penetration right now. That's what's happening on hyper-converged. That's what we're going to see over the next year. Okay, so one of the things to think about is why do people buy hyper-converged and when will they buy hyper-converged in place of enterprise storage? Because, like I said, enterprise storage isn't going away. So the reason that you buy hyper-converged is because of TCO, total cost of ownership, and management simplicity. Now, it turns out I'm going to talk about performance in a minute. So performance has to be as good, right? But what you're finding is it's about management simplicity. That's what's driving customers to go resolve that economic stress. How do I go and use, in essence, right, how do I turn on the storage functionality in a vSphere environment where I'm already using the compute? And so what you'll find, right, is we ask customers, this is a recent survey we did, 250 of our VSAN customers, we asked them, they could only pick one. What was the number one reason why you bought our product? So 40% said it was simplicity. Now, there were other reasons, by the way, scale-out architecture, better performance, avoiding a SAN upgrade, but the number one reason, right, was to go and get the simple deployment model that they could go and minimize both CapEx and OpEx. That's a TCO model. That's where VMware has historically done well. Right, is going to basically get a total cost of ownership model of consolidating on hardware. All right. It's also interesting with Flash, right? Let me talk about Flash for a minute. As we've gone to use Flash, and Flash is a natural link to hyper-converged because Flash is being used in hyper-converged not for the ultimate low latency performance, although I'll show you the results in a minute, which are pretty stunning, but because it's eliminating the time spent tuning performance. So Gartner did a recent study showing that you could get 48% of your storage management time back by eliminating performance. So let's talk about performance tuning for a minute, right? Performance tuning is almost the worst of things because it takes your best people. Anybody who knows, right, when a performance problem comes, you have to understand whether it's the compute, the application, is it the network that changed, right? It takes your best people to go and diagnose a performance problem. And secondly, those performance problems are always urgent. And so what Flash is doing is eliminating the time spent tuning performance. And I'm just going to bring you an example. Do you remember when you could fill up a notebook drive? Remember that, right? When a drive was actually the capacity? Do you remember those defrag tools, right, that we used to use, right, to go and like move data and they have the little blocks moving everywhere, right? We did a lot of work to get around a capacity constraint of a notebook drive. Come on, does everybody remember that? You must remember that, right? That we spent a lot of time, right, doing that, and we don't do any of that work anymore. It's all gone. And customers overbought the amount of capacity routinely so that they would never have to do that work again. Does that make sense, right? And that's what they're doing on performance right now. Customers will overbuy on performance because it's not that expensive anymore. We have some great announcements this week with Intel on NVMe, with SanDisk WD on NVMe support. You should see the numbers, right? 50% improvement, 150,000 IOPS per node, right? As we look at how flash is. Now, what that's being used for is to eliminate tuning so that the user experience is outstanding, right? Customer sat numbers for all flash are off the charts. So you're just going to see, right, that you can get more VMs per density, and hyper-converged, right, implemented now with vSAN gives you flash performance that allows you to go and get your management time back. We had a great meeting with a vSAN customer, and they described it this way. They said, I used to spend my days looking down, and now I can look up. Right? I looked down when I was trying to manage the infrastructure, and now I could look up because I could go and start managing, get back to managing the business. Right? That's the sort of dynamic that Flash is giving you with 3 times the number of VMs. We've got another customer quote here, right? The University of South Carolina Upstate said they were immediately getting faster storage performance, right, and seeing 50% TCO savings over 3 years. It's those types of stories, right, that tell you how Flash is revolutionizing, changing what customers are spending their time doing, right, what we're spending our time doing. That's the impact of Flash. Now, on performance, we polled our customers to say, what sort of experience were you getting on performance? And the idea was we wanted to see, were you getting the same or better performance? The numbers here, so 94% of our all-flash customers are seeing the same or better performance for the enterprise storage that they replaced. Now, 83%, by the way, if you want to know the actual, 83% was better, 11% said the same. So what you're seeing is just a massive uptick, right? Now, it's admittedly a little bit of a low bar, right? A lot of the storage we're replacing is older, like disk-based storage, right, or hybrid systems. But the idea that you can get the same or better performance, right, using Flash, right, very interesting. Okay. As a result, we're also seeing that vSAN customers, so this is, again, self-reported numbers from our customer base, vSAN customers are quickly migrating from the fringe applications of things like VDI or test dev into mainstream applications. So now a majority of vSAN customers are running business-critical applications. That's pretty interesting, right? If you think, now, vSAN is following exactly the same profile that vSphere did. Right? If you think about vSphere first came in from the fringe, from the edge, right? It was like DNS servers, DHCP, basically. We used to call it crapplications. I don't know if you remember that, right? Where it was applications that you didn't care about quite as much got virtualized first. That's what we saw with vSAN over the last 2 years. We had things that were on the edge. Now what's happening, though, is the TCO benefits are so real, so compelling, that we're now driving this into the mainstream, into business-critical applications. And as a result, what you'll find is that the now requirements, right, for vSAN about things like data protection, right, about file services, right? You're seeing more mainstream enterprise storage application requirements come into this space, and we're delighted to, we're going to be talking to Chris about that a little bit, and we're, delighted to hear from you about things that we could be doing. We'll have a Q&A at the end of the session, by the way, so save up your questions. Okay. By the way, so there are still great use cases, if you will, for VDI, for example, as management clusters. If you want to do microsegmentation with NSX today, we've got a great solution for going and using a vSAN cluster as that management cluster. Fantastic application there. Any remote office, robo applications for retail, for example, healthcare, banking, the ability to have where you don't have specialized support resources, the ability to take vSAN, right, and use that, leverage all the skills. You'll find that customers are, we're looking at how to go and leverage skills that are in a central location, right, where you don't have those specialized skills in remote locations. All good applications. What's interesting, though, is how much and how quickly we're getting a very long tail. I mean, the other implication of this, by the way, if you're a vSAN customer, if you expect to have a wide variety of applications running, it's a great thought about all flash again. Because if you think about all flash, what happens then is you don't have to go and micro-tune, right, what the performance characteristics will be. You'll be able to go and drop whatever application you want onto vSAN and be able to support that, right, without jeopardizing any sort of customer sat experiences down the road. Okay. The vSAN strategy, right, is an interesting one in that, VMware from a software standpoint is working with a wide variety of our server partners And so we have 15 different server partners building what we call vSAN-ready nodes. And so what we've done here is we've stripped out all of the implementation risk. So the idea is we let our partners go and differentiate and compete on the basis of their server expertise and of the management for those servers. And then we provide the software that allows you to aggregate the storage across that, but we qualify and certify those nodes so that we can strip out the risk that makes sure that they're going to work and be deployable in the field. And so that minimizes our support elements. And so from that standpoint, 15 different server suppliers. We have 164 different platforms today. So you've got the flexibility, right? If you're an HPE shop, for example, great, I can go pick the blade that I want to go and run on, or the rack server, or I can pick whatever server I want that's qualified and now deploy that with vSAN. I get the flexibility there. What we're finding is that a large number of customers have, strong server preferences. And so they want to go and choose the server, right? And they may have different servers by geography even. So we have customers, for example, who will have one server vendor who they use here in the U.S. and a different one in Malaysia because they have different support, different spares, right? That type of flexibility is what the vSAN software model allows you. Now, we're also partnered closely with EMC to offer the EMC VxRail product. So what we've done here is for customers who say, I actually don't care as much about the server. What I really care about is a single point of support. I want to have a fully integrated, pre-configured system. This is the fastest go-to-market product. I can buy this instantly because it's all pre-configured, ready to go. And the EMC VxRail product, right, now gives you all of the same vSphere ecosystem integration, along with one other very interesting thing. So it's integrated with data protection from EMC. And so now I've got backup, right, integrated with the product, right, in a way to go and build that out. If you want to see all of these products, by the way, the vSAN-ready nodes, as well as the EMC VxRail, they're available. You can see them out on the Solution Center. Most of them are available in the what's called the HCI zone. And so the HCI zone, stop by, right? There's all different partners basically showing, hey, here's how you can build out a vSAN-ready node on the server of your choice. Okay. So what we're calling the blistering pace of vSAN adoption, right? 5,000 customers. This is the fastest growing product since ESX was launched inside of VMware, just to give you a perspective. So in other words, we're coming from the edge into the core, and it's happening actually at a rate that's faster, right, than what we saw early on. That customer adoption rate right now is in part because we've got all of the benefits of vSphere, right, already, right? That training is already in place. And so you can think about this as basically leveraging all of that existing skills that you have and basically turning on the storage functionality within this. And so that bookings growth also, 200% bookings growth. We've got now over 100 over 100 countries represented, and 400 of the top Fortune 1000. So you'll see that number growing, dramatically as we go and, continue to announce results this year. Also, vSAN is not specific to a vertical. I think that's interesting, right? We're seeing it across whether it's manufacturing, healthcare, retail, banking. We're seeing it come across all of those different areas. And so we've just got a really, I think, lively ecosystem, participating in vSAN. And with that, what we'd like to do is invite Chris Millett to come up from Chevron. He's the lead technical advisor with drillings and completions. And so please welcome Chris Millett to the stage.
Thanks, Lee.
Yeah. Awesome. So we have a couple pictures here, Chris. First, welcome and thank you for joining us. So maybe you can tell what's with the boat.
Sure. Yeah. So that's one of our deep water drill ships. Historically, that's where we focused a lot of our compute resources and like rig kits that we've deployed over the last few years. Historically, it's been blade chassis, the dedicated enterprise storage, NAS storage.
Yeah.
And so that's really been our focus point for the last few years. But now we're starting to kind of bridge the gap and look at our land-based operations, which are also our lower cost. And in the current economic climate, like oil and gas, that's where we're focusing a lot of our resources right now.
Oh yeah, right. So a lot of economic pressures, I think, right. In the oil and gas space with oil prices and things. Mm-hmm. What are we looking at in the middle? So you've got looks like a cooler.
Right. So that's actually what we call our kind of rig IT platform. So that is our new standard that would work on both land and our offshore operations. It's basically a 2U server with multiple compute nodes as well as integrated storage and basically our core switch that connects everything together. And it's housed in different configurations. In this picture, this is for a land-based operation that's actually on the right side, and that's inside like a Pelican case.
Got it. So you got land over on the, I guess that's right. Yeah, you got
right. Yeah.
So tell me about like support and maintaining all these systems. I mean, how do you work all that?
Sure. I mean, exactly kind of what you commented on earlier around the it's kind of having all the right resources in the locations is a struggle, and what we've been working to do is it's very hard to have every discipline, storage, network. Right. Compute, application support, all in these like remote locations. So what we've been working on is building the kit and then training people on the kit itself, so that they might not be an expert on any of those particular disciplines, but they're an expert on how we use those.
Now, when you talk about different locations, like when I think of different locations, like I live in Palo Alto and came to Las Vegas, but you told me about some locations yesterday that were a little bit more out of the way, right?
Sure. So like on the left side with the drill ship, those are locations like offshore Gulf of Mexico, so that's several hundred miles offshore, all the way to West Africa, Liberia, Angola, Nigeria, then going into places like Kazakhstan and northern Iraq.
Wow. Have you been to those places?
Most of those places, yes.
Wow. So you can imagine, like, the train. You told me an interesting story, actually, about even just shipping replacement parts, right? It can be kind of an interesting area.
Yeah, right. So one of our biggest challenges is even getting it. So for, like, especially on the offshore side, if we would have a part that would fail, we have to either put it on a helicopter, and that's probably a 24-hour turnaround, or in some places have to ship it to a location and then take it offshore. So having, fully redundant systems, no single point of failure is a must.
A lot of people who know me know that I'm kind of an enthusiast on Flash. You told me one of the funniest, I thought, value propositions for Flash was getting under the FedEx limit of shipping, was it?
Right, that is true. So we're actually moving from a kind of mixed, both a rotating and solid state. One of the biggest benefits of moving to all solid state is the weight for shipping.
You're getting under like a 120-pound limit or something?
Right.
Yeah, I thought that was interesting. So I'll use that in my next blog. But tell me about them. When you chose VSAN, or what were some of the what were some of the criteria you used, and how do you think about your experience so far?
Sure. So one of the biggest challenges is space. Like even though these like that drill ship looks huge, trying to we probably have about one rack to fill all our like IT gear and requirements.
Right.
So form factor is a big requirement. Power, cooling is sometimes challenging. So with having something that we wanted to stick with a 2U form factor for compute and storage. And so having that, we had to look at, okay, well, what could we do to maximize that without having to move to a separate storage appliance?
How about NSX? Were you thinking about NSX and how to integrate that? What's your thinking about those?
Yeah, those are things that we're looking at, like in the future. Software-defined networking, doing more application containers, and what we're trying to do on the drilling side is that since we maintain the ecosystem at the rigs and we pretty much know the user environment, the applications, we're able to kind of test some of those newer technologies first and take those lessons learned back to our central IT organizations.
Would you characterize Chevron as a risk taker?
No. We are risk adverse.
Risk averse, right? So it's kind of interesting, right? That, as you think about how you go and move today with VSAN, and then think about adding new technologies or other technologies into the mix going forward. Great. Any other things you want to add before? We're going to bring Christos up in a minute, and then we'll bring you back for questions at the end. So if you have questions for Chris, So any last things?
Yeah, so far, probably the one kind of caveat that's been with VSAN is around Virtual Center, actually. So like one of our challenges is having to kind of pre-stage these and then move them to another location, change networking most of the time, and so having to go back and re-IP, and sometimes that management aspect
is quite something, Right. So we'll be bringing all of these management aspects. It's so interesting because management turns out to be the number one. Right, if you think about the number one issue about how we can go and improve the experience going forward. So terrific. Well, thank you so much for coming up and sharing the story. We'll bring you back up for a Q&A at the end.
Thank you.
Really, a hand for Chris, if you would, right? And with that, I'd like to introduce our Chief Technical CTO, Christos, the
I'm going to hear you pronouncing my last name. Give it a try.
Karamenoulos.
Okay, not too bad, not too bad.
This is for you.
Thank you.
All right, thank you.
So, very interesting presentation from Chris. Actually, I was really excited to see this because my first job ever as a summer intern was writing software for doing analysis of the state of drilling, operations and wells. And the best part of my job was going onto the rigs and collect the tape cartridges. So I was looking forward every week to do that. So let's move on. For the rest of this session, I'm going to help you look a little bit behind the scenes, the technology behind the numbers and the benefits that Lee described earlier. There are three main properties that differentiate virtual SAN in the market. First, predictable performance with very low CPU utilization. That is really a major requirement in hyper-converged infrastructures. Second, enterprise-grade features for data availability and integrity. Last but not least, operational efficiencies, easy and scalable management of infrastructure and applications that approximates the simplicity of public clouds. Let's look into each of these areas in more detail, starting with performance. I'm showing here a few numbers that will give you an idea of the scalability of the product. But I will start with one comment. We designed virtual SAN from the get-go to be a storage platform for hyper-converged architectures, based on an experience of more than 10 years of virtualizing enterprise storage. I assume that most of you in this room have used and have some experience with VMFS. How many of you have had problems with scalability? For example, the number of VMs that you could put in a single VMFS data store. Let me see hands. Quite a few. So yes, VMFS is actually the most enterprise-hardy, popular cluster file system in the market, but it has certain scalability constraints because those are inherent in a cluster file system that requires coordination for every time we do some metadata operations in the entire data store. So vSAN instead has been designed as a clustered storage that has no single point of control, no single point of performance bottleneck. As such, it can scale linearly as the number of hosts and the number of VMs in a cluster grow. So in this diagram here, I show you performance, I/O operations per second, as the size of the cluster goes from 4 hosts to 64 hosts. I'm showing numbers for both hybrid configurations and all-flash configurations. You see that in both cases, scalability is linear. And we exceed 6 million IOs per second for all-flash 64-node clusters. Even more important, in my opinion, is the predictable latency. Not only average latency, but also very low jitter. This really results in very predictable quality of service for your applications. In the case of all flash, we can consistently latencies that are well below 1 millisecond. And if you want to see more data, especially performance data with real applications like Oracle RAC, Microsoft SQL Server, SAP, even HANA, join our session later on today together with Rollison, where I'm going to talk about more details about performance and how we achieve performance with very good performance with real applications. So let's look a little bit behind now the scenes, the technology that allow this kind of great performance behavior. First of all, vSAN has inherently a tier storage architecture. The high-level idea is that combine the capabilities of different technologies with different costs to come up with really a great total cost of ownership. Great performance, scalability, without breaking the bank, right? There are two fundamental configurations we support today. One is hybrid configuration. We have a tier of distributed caching consisting of flash devices that is used both for read and write caching. While in the back end, we have magnetic disks that are used for the capacity tier to store the bulk of the data. The idea here is that you get flash-like performance out of this caching tier with a cost that approximates that of a magnetic disk, because traditionally magnetic disk had a lower capacity cost, dollar per gigabyte. The other configuration is all flash. Here we still have two tiers, but for very different reasons. We use a first tier consisting of small, high endurance, and therefore expensive flash devices to act as a write buffer, so that it can absorb the vast majority of the write operations that come from the applications. And because of overrides, deletes of blocks after they're written, eventually we destage only a small percentage of the data from the caching tier to the backend capacity tier. So because of that, we can afford to have SSDs with low endurance and therefore lower cost as the capacity tier. And the big advantage is also those SSDs are also used to deliver the vast majority of the read performance out of your system. So, and also actually in both cases, we use local, small amounts of RAM for data caching close to the CPU where the actual application works. Now, the pros and cons of each of these architectures is that with hybrid configurations, traditionally, at least so far, you would get better overall cost for your infrastructure, but there is a catch. As Lee alluded to, you have to be very careful with the sizing of your caching tier, because if your applications evolve or if you don't do your analysis accurately enough, and the active working set of your applications exceeds that of your aggregate cache, there are severe performance implications. All flash, on the other hand, is much more tolerant and forgiving to sizing issues and mistakes. So even if you don't get quite right, performance is still going to be good, because there is no real cache to size according to your workload. That, in combination with the fact that now the cost of capacity for flash devices, especially the old-fashioned NAND-based devices, is going down, all flash is becoming the predominant model of configuration that our customers use, especially since we shipped VSAN 6.2 back in March, which comes with a range of space efficiency features, deduplication, compression, and erasure coding. So this is the model going forward. And in fact, I expect this tier architecture to really work very well in the future for a number of reasons. Let me explain a little bit what is going on. There is a shift in the industry. The graph I present here, the curve, reflects the trade-offs between capacity cost and performance for the available technologies we have today. You see that magnetic disks at the bottom left of the graph are offering really low capacity cost but at a very low performance. SSDs are more expensive but have very effective performance. Dollars per IOs per second are quite low. And NVMEs, the newer generation devices, are even more expensive, right? This is the reason that hybrid architecture made sense so far. However, things are changing already. This curve is moving up and to the left. Essentially, NAND-based SSDs with new technologies like 3D NAND are having capacities that are much bigger, and the cost of those capacities is coming down rapidly. So at this point, we have already crossed over with SSDs having capacities cheaper than enterprise-grade SAS magnetic drives. And NVMe prices are also coming down, so are becoming much more affordable, especially the devices that have NAND inside. But now we have a new generation of physical storage technologies called, in general, NVRAM, like Intel's and Micron's 3D Crosspoint. Those are going to come in initially in the form factor of an NVMe device on the PCIe bus, and down the road are going to be available in a couple of years, I believe, in a DIMM form factor on the memory channel. That will be offering huge performance, millions of IOs per second from a single device. Latency is very low, consistently in the couple of tenths of microseconds, not milliseconds, microseconds. Now, for first time, those devices have latencies, storage devices have latencies that are lower than that of networking round trips. What does that mean? We're going to be using this device in a couple of new ways. First, we'll be storing their metadata, like deduplication hash tables, data checksums. Those kind of metadata operations that today are a little problematic in all storage systems because they introduce I/O amplification. With these low latencies, those I/O amplifications will be practically masked away. The other way to use them is as persistent caches of data next to the CPU where your workload runs, where the data can be accessed with minimal latencies, with amazing implications in performance. This is the future, and this is what we are designing and evolving virtual SAN to accommodate for. Of course, now, hopefully I convince you that vSAN performance rocks, but the question is, can you trust it with your data, right? This is where enterprise readiness comes into the picture. vSAN offers a number of features, first of all, for data availability. We support not only synchronous replication, RAID 1, but also erasure code, specifically RAID 5 and RAID 6, as software-based mechanisms for data redundancy. The user can specify by means of policy what level of protection they want, and also specify where they want a performance-optimized or space-optimized redundancy. For performance optimized, we use RAID 1. For space optimization, depending on the level of protection you need, RAID 5 or RAID 6. Very importantly, you can specify those requirements at the granularity of an individual VM or even an individual VMDK. You need better protection for your database VMDK and perhaps better performance than for a volume that contains, scratch space, all right? All those policies are automatically enforced by vSAN. You configure every VMDK, distribute it in the system to comply with those policies, and automatically monitors and even remediates any issues. vSAN protects against, of course, host, device, network failures. It is rack-aware, if you wish, so we'll never put two copies of the same data on the same rack in that case, and even supports stretched clusters across two sites for protection against an entire site disaster. This is a feature that is available only from the highest-end enterprise storage systems traditionally. And in our case, it is natively integrated with vSphere, HA, and DRS. Beyond that, we have features that deal with the integrity of your data. Software checksums, end-to-end, from the moment that the data leaves the application and I/O is issued from the application over the network and all the way onto the storage devices. Moreover, in the background, we run continuously a data scrubber, which with practically no overhead ensures that you are protected against bit rot, even for data that is not accessed very often. So these are two examples of enterprise features. And moving forward, we're introducing even more. One of them is native data at rest encryption. This is a new feature. It's going to be available at some time in the future. If you're really interested in this, I encourage you to subscribe to the next vSAN beta that is going to be announced, I believe, this week here in VMware, right? So go and take a peek at that. We implement encryption using AES 256 XTS mode, and we're actually working to make the feature and therefore vSAN FIPS 142 level 1 compliant, which is a requirement for many federal agencies. The feature is going to be integrating with practically every key management service that supports the KME protocol, and we're already testing this with most main KMS vendors out there. I'm outlining just a couple of them or a few of them here. So this shows the commitment we have in enterprise readiness for vSAN. Now, I must state that good solid storage enterprise readiness is a prerequisite for making this into the private clouds, the enterprise data centers of our customers. But what most customers care at the end of the day when the rubber hits the road is the operational model of the product. How much effort does it take to develop the expertise and the knowledge to use the product? How much work it takes to integrate the operational model of a new product into existing processes and management workflows, or automation and scripts that you already have established to manage your infrastructure. This is really where vSAN excels for VMware environments, because it is a native extension, the default storage, if you wish, of vSphere. And the management is what makes the difference here. vSAN has been designed not as a separate silo of storage with its own storage console for management and some separate APIs. It's an enterprise storage product that is managed by extending the existing abstractions, tools, APIs. And by the way, we have an API-first approach in our design and development. And it can be used with mechanisms and tools that are very familiar to those 500,000 customers of VMware that Lee mentioned. So it's much easier to integrate in your existing workflows, much easier to use your favorite scripting language and write against vSphere APIs that now are extended to cover storage properties. And what does this management entail? It supports scalability in 2 dimensions. First, infrastructure management, where we offer tools from day 0, where you install, configure, and even check your infrastructure, including performance checks, to make sure that everything is configured right, everything works right before you put your production workloads onto the vSAN cluster. Into day 2, where we help you not only monitor the hardware infrastructure, the network, the servers, end-to-end, not only storage, but everything. We're even allowing you to monitor the performance and do analysis that goes all the way from the application, the VM, down to the individual device that is being utilized to store the data. And now, today, we offer a lot of data to our customers to do a lot of, do this root cause analysis and potentially take remediation steps themselves. In the future, we're going to move even further out. We are working on a really exciting new project that collects a lot of this data from our management services on-prem through telemetry, VMware's Phone Home product. And we crunch that data in VMware's public cloud. So, and our goal is, instead of providing you raw data, to provide you with specific answers, suggestions, pointing out, doing the root cause analysis for you, and even suggest things like optimizing your infrastructure, your configuration, your policies. Because what we're doing also, not only getting the data from one customer, but having data now from 1,000 customers. And we can correlate using modeling techniques and statistical analysis that allow us to infer conclusions from all the infrastructure out there. So the idea then is to go up the stack, provide you these sophisticated services in a way actually with features that are going to be delivering very rapidly because you're developing them on the cloud, our cloud, and you don't have to wait for software to ship every 6 months or 12 months or whatever is the cadence at any point in time. But here's the nice thing. All the results, all the suggestions, all the information fed back to the customer is going to be provided through the vSphere UI extension. You don't need to go and use yet another public cloud portal. This is like a combination of best of both worlds, right? The other dimension of scalable management is application lifecycle. With a policy-based approach we have introduced initially with vSAN and later with VMworld, we have really made a big difference in how applications are provisioned, storage is configured, and managed during the life cycle of an application as requirements change, the infrastructure changes, and so on. This has resulted in getting rid of all these manual steps that are traditionally involved in provisioning and configuring storage volumes, LANs in storage area networks, with great efficiency and simplicity benefits to the customers. We take this model now a step further, and we're going to expand this policy-based approach into data management and data protection to deal with the life cycle of your data, not just the applications, not just the compute part of it. The idea here is we're going to be introducing policies that capture properties such as data protections, recovery point objectives, retention policies, which availability domain, perhaps on a public cloud, your data can reside and where not, or security policies in terms of encryption, access control, and attribution, right? So ultimately provide the same model to manage your data on your private infrastructures, but also across clouds. And you should expect to hear a lot more from us in this space. Now, one question would be fair to raise here is that if data, is spread across private and public clouds, isn't that a big risk? And yes, of course it is, and all of us, the industry at large, are very aware of that. So with this global data distribution products coming along, you need solutions for overall data governance. And this is another area we'll be working on, collaborating perhaps with some partners out there, but the idea is to be able to have visibility across your entire infrastructure, private, public infrastructure, and be able to control what data lives where, who accesses the data when, and what is happening over the life cycle of the data. Now, since we're talking about data, I want briefly to mention the fact that actually data is already escaping the traditional boundaries of IT organizations and transactional databases. It's very common to siphon data out of an Oracle database or a SQL database, usually because of needs of lines of business, which need to crunch that data, analyze them, do warehousing, or run some analytics for their own business purposes. Often, this analysis is done by a new generation of applications called cloud-native applications that are typically developed from the get-go to be running on public clouds. So the first parts of a company that move to public clouds, say AWS or Google or Azure, are actually lines of business that find the economics of public clouds and the agility they offer and the on-demand infrastructure very desirable for this kind of business needs, these new IT requirements they have. So these applications are inherently designed to be distributed. Properties like availability, fault tolerance, even resource control are natively implemented by the applications who consist of many fine-grained, small microservices, right? So how do these applications work? It's not just the data that is a compelling story here, but also the fact that we use containers to package and deliver those applications, and compatible cluster managers to deploy those applications and control the runtime. All this have to be done with an operational model that is very agile, that can be used by developers, not the traditional IT guys, and scale to thousands of servers, perhaps across physical boundaries. This is what I consider to be the ultimate goal in terms of operational efficiencies. But at the end of the day, there is also another need, storage. Today, those applications make very simplistic assumptions about the properties of the underlying storage. And so in many cases, you need to build a lot of the data availability, reliability, integrity features I talked about earlier into the application, into every single application. And this is something that is not scalable. So we're working actively to build a new storage platforms and abstractions to support this cloud-native application model. I encourage you, if you're interested in this, to go by the VMware's Office of the CTO booth at the Expo to look at some demonstrations there of a new technology, or perhaps join my vision session on Wednesday on storage. To wrap it up, what is VSAN offering to you guys as an IT organization? It's a future-proof storage platform, right, that lets you ride these evolving technologies of storage that I talked about earlier. It allows you to extend the existing, a very efficient operation model from infrastructure to application lifecycle into data lifecycle into the future, where you actually get the advantages of many of the public cloud management features into your own enterprise data centers. And last but not least, offering a single platform that works both for traditional enterprise workloads as well as new cloud-native applications. So, Lee, do you want to help us, relate this back to all these
Thank you. Christos,
cloud strategies?
A round for Christos, if you will, yeah. So, yeah, in your introduction, I didn't say that Christos is a fellow. I don't know if you realize this, but there's only 5 to 6 or 7 fellows, six fellows in the company. So, I really encourage you to go and attend these other sessions, right?
Don't hold that against me.
It's more important. I won't. We've got 2 things in this that I just wanted to follow. You saw this diagram in Pat's keynote, which is about how we're integrating all the way down into any cloud. And, specifically, we're going to be talking, and in tomorrow's keynote session with Yanbing Li, who's right here, by the way, so wave Yanbing, right? So she'll be leading this session tomorrow in the keynote about how we're taking and extending then across the VMware Cloud Foundation, across any cloud, any place, any device. All right. And powered by VSAN. So with that, what we'd like to do is just open it up for questions. We've got a little bit of time. Oh, these are the sessions, by the way. So the general session, 9 o'clock tomorrow, yes, as well as this 3 sessions that you're leading, right, some with Rollinson. And so you'll see these, both enterprise-grade storage, the evolution of VMware Virtual SAN, and then an industry roadmap from storage to data management. So with that, we'd like to go and open it up actually for any questions. And Chris, why don't you join us up here, see if there's any questions that anybody's burning to ask. Any questions? Yeah, please, here's a question. Come on up, guys.
Hello. Can you compare and contrast vSAN with vVols from a technology and a competitive standpoint?
So, as I described, with vSAN, we introduce a fundamentally new management model for application lifecycle. This is the policy-based management, which is the same model verbatim between vSAN and vVols. So essentially what we did is we took the control plane of vSAN and opened it to third parties through the vVol program. So the same way now you have automated ways to provision your storage through policies for vSAN, you can do exact same thing with vVols. And given the design being a data-driven design, we give the capability to storage vendors to introduce new innovation, new features that are reflected in policies that are available by perhaps only one vendor. So essentially, we get the same benefits I described for vSAN regarding application lifecycle, or even data protection, data management lifecycle, which is because I've seen already some of our vendors start introducing some of those data management policies. So the idea is the control plane is the same. vSAN is VMware's own storage product, as I said, very well integrated with vSphere, offers integrated infrastructure management, which practically no other vendor can do because we virtualize now compute, storage, and networking. But as far as the policies and the control plane of applications data, this is shared between vSAN and VMworld. It's exact same code base.
So why would a customer choose vSAN versus VMworld if they have two options, two alternatives?
Yeah, that's a good question. And obviously, first of all, we believe that we have developed a very compelling storage product, right? Compelling with all those other vendors which are partners, but also competitors. But I think really the key differentiation is in the operational efficiencies of the infrastructure. I talked about that, right? You go to vSphere, and now being a vSphere administrator, you don't manage just your compute, but you also manage your network and storage with one UI, one set of APIs, the same workflows, the same, scripting language bindings. So this is the key value.
Chris, you might have a perspective on this, sure.
I was thinking the same thing, that was our big reason for choosing vSAN. Our performance, ease of use, setup, configuration, and administration.
Right. And so now you've got common management. For folks who are using enterprise storage, right, we've got the ability to go leverage those same kind of semantics and management capabilities right into the enterprise storage, which isn't going away, right? At the same time, what we're finding actually most of the time is vSAN is augmenting. It's augmenting an existing environment, right? Not replacing it in
And all of us wear two hats here. One is the hat where we are working on our own storage products now, but our BU and very substantial percentage of our BU resources dedicated to support our partners, including VMworld partners, but also more traditional storage partners, VMware IO filter partners, and so on and so forth.
One last question.
Sure.
I thought I heard that VxRail was not going to be supported last year, but it's back now. I'm confused about that.
I didn't hear that. What was it?
The VxRail.
VxRail. There was some questions about the level of support,
VxRail?
apparently, last year.
I thought I heard that it wasn't going to be continued anymore last year.
Oh, yeah. So, actually, last year we had something called EvoRail. EvoRail that was slightly different. And it's interesting to think about what happened there, right? EvoRail was I would say an effort to go and try and contain the range of hardware options. The challenge on EvoRail really was that it didn't give the partners enough flexibility in terms of how they would go and build out products. It was just too restrictive right at that point. So now with the vSAN-ready nodes, right, vSAN-ready nodes are now, right, full on, right, as I mentioned, 164 platforms from 15 partners. So vSAN-ready nodes have taken the place of what was EvoRail. And now the VxRail product, right, which is what EMC has built, is a completely integrated product. Right. What they've done is taken and built their own version, right? That's completely integrated on their, with their own hardware and software in that case.
So VxRail is EvoRail done right.
Yeah, exactly, right, exactly.
Thank you.
Yes. Any other question? One last question before we go. Yeah, question, please.
Sorry.
Over there.
Oh, I'm sorry, I missed you. Yeah, there was one over here first, if that's okay. Yeah.
We'll take both questions.
Yeah, we'll do two. Go ahead.
I'd like to understand your roadmap for compression as a cluster entity, not as a data group, because as you see, as your scale of computes increase, 64 nodes in a cluster, you're going to find much more redundancy across disk groups, right? Which is an important aspect of what other SAN vendors or NAS vendors do sell.
Let me. You know about a vendor that they were trying to upgrade their software of a global duplicated all-flash array, and because of the architecture of that, the vendor had to ship new arrays because they could not upgrade in place. Sure. So let me make a point here. We made this architectural decision after a lot of consideration. So in theory, yes, if you have global deduplication across your entire cluster, for example, you may get a little better deduplication results. Mm-hmm. But on the other hand, you sacrifice a lot in terms of the distributed architecture of your platform, the tolerance to many failures in different components of your platform, the ability to have fine-grained policy-based management where each VM can be configured with in different dimensions, whether that is the redundancy, striping, caching, and more features down the road. Those are the downsides if you have a global deduplication, because then essentially everybody gets more or less the same quality of service. You cannot have that much differentiation. So what we do here is we find a trade-off that gets us the best of both worlds, right? We can have very effective deduplication, in general, space efficiency rates, and without really sacrificing the scalability, the fact that we don't have any single point of metadata control, and ultimately the total cost of ownership. Because at the end of the day, don't look at the details of the numbers under the covers. Do you get 7 or 8x deduplication? Look what is the price you pay for that performance, for that the enterprise readiness features.
Oh, my question actually had 2 parts. I'm sorry. There was the inline part of it for compression dedupe, and then there's the cold store tiering of data across nodes in VSAN.
So you are asking for an answer about what the inline deduplication?
No. My question basic was about dedupe and compression, but there were 2 segments of it. There's the inline part of it, and then there's the background part of it to cold store across nodes.
Yeah, I'm not sure I follow the question.
Okay, so I'm trying to repeat it again. So the compression dedupe has 2 aspects. There's the inline part of it, and there's the background deduplication and compression of moving data in your primary storage into...
I see. Okay, got it now. Okay, thank you. As you know, many storage systems have been doing, and actually Lee can talk your ears off about that,
exactly.
Doing asynchronous deduplication in the background. You know what that means? You never know how much capacity you need. Because you do not have a deterministic way to
I mean, this is just an interesting way that dedupe and compression, right, historically in a disk-based system, were always done as a post-process, right? And the reason was that the disk was relatively slow, right, and the capacity was cheap. And so you would go commit data onto the disks and then come back later, right, and do post-process, right? That's the way most disk-based companies really approach this. Now, flash was actually inherently different, right? First, because you had low latency on the flash device, you wanted to go and commit data onto the flash quickly in order to get the advantage of low latency. That was number one. Secondly, you wanted to write the minimum amount onto the flash because, well, it was relatively expensive. And third, from a write endurance standpoint, you didn't want to write data you didn't have to write, right, so that you could go and use the lowest endurance, cheapest flash. Right? So what we found was that you would go and what was a post-process in a flash world became inline. And I'm going to suggest, right, that like a hyper-converged scale-out architecture is actually the best suited for this because you have the most CPUs to apply. And it scales out linearly, right? As you go and add nodes, for example, you're adding CPU power, right, to go and basically get, so that the ability to get linear scalability, this is one of the things people have asked, like, well, what's happened now? What happens now on HCI? And you can think of NVMe as being the tipping point, tied to, like, if you look at, like, Skylake architectures coming from Intel later on, I mean, the power that we have now to go and do these inline processes versus a classic 2-head, array, HA pair is dramatic. And so this is what you'll see, right? And actually, we rely really mostly on inline, right, where other architectures, right, have to go and do post-process because that's the way they were architected from the start.
So yeah, there are 2 aspects, just to wrap this up, because there is also the question of the CPU consumption, right?
Sure.
And because of the architecture of VSAN and this strong integration with the hypervisor, if you see, and I suggest you join some of my other sessions where I have actual data, you see we have minimal CPU overhead because of the duplication and compression. That is the other big advantage.
We had one, I'm sorry.
May I make a quick question, quick answer to his question?
Oh, sure.
Okay, so...
VMware is one of our lead engineers in VSAN, so...
Perfect.
So, regarding the global dedupe,
yes.
So it takes a lot more extra complexity and CPU and other stuff, but the expected benefit actually is a lot smaller than you would imagine to do dedupe across nodes. Because dedupe is useful when there are many, many copies. Reduce 1,000 copies to 1 copy or to 64 copies in case of a 64-node cluster doesn't make too much difference. So assume the total data capacity is 100, and 50 of them are unique data, which cannot get deduped anyway. The other 50, whether you reduce them to 0.1 or to 0.64, doesn't matter. So it's also a trade-off that we make that between the complexity and how much benefit you can get.
Yeah. Awesome. Folks, I suggest we take this further offline.
Yeah, let's take this offline. We're going to have to leave, actually, because of this. I want to thank our panelists. Chris, thank you very much. Christos, thank you very much.
Thank you, guys.
They're all great.